we will learn about microcomputer systems in this lesson. Microcomputer is the abbreviated term for microcomputing system. First, let's briefly review the development history of microcomputers. The world's first modern electronic computer was designed and manufactured in the United States in 1946. It occupied an area of 170 square meters with a power consumption of 150 kilowatts and had a computing speed was 5,000 operations per second. From this image, we can see that the computer was enormous and based on the data, its computing speed was relatively slow. The key point is that only trained professionals could operate it. From this perspective, the computer was highly limited in terms of usability and widespread application. With technological advancements, computers became increasingly miniaturized. This is a classification of computers based on comprehensive indicators. Now, let's look at the components microcomputer. From the perspective of the entire system, microcomputers are divided into two parts, software and hardware, namely the software system and the hardware system. First, let's examine the software system. The software system refers to the programs installed on a computer's hardware, including system software and application software. The common system software includes Windows, Apple's OS, and mobile OSs like Android. Application software refers to programs developed by software engineers using system software to address specific problems. These programs are designed to meet various user needs. Common application software includes Office suites like Office and Excel, as well as communication tools like WeChat. Now, let's look at the hardware system. The hardware system includes the main unit and external devices. External devices refer to all equipment outside the main chassis, which exists to facilitate our use of computers, such as keyboards, mice, monitors, speakers, etc. This includes the motherboard, fans, hard drives, etc. The motherboard also contains the CPU memory modules, buses, and I/O interfaces. This course primarily focuses on the working principles of components on the motherboard and software programming to achieve specific functions. This diagram illustrates the connection relationships between the CPU memory, buses, and I/O interfaces. The bus not only connects the CPU and memory, but also links the CPU and I/O interfaces, enabling communication with external devices. There are three types of buses: the address bus, control bus, and data bus. Based on these functional allocations, the address bus is abbreviated as a BCB and DB. Whether reading or writing data, the CPU always issues the instruction first, meaning the address sent on the address bus is always transmitted from the CPU to other devices. The address bus operates unidirectionally, transmitting address exclusively from the CPU to other devices. Control information may be sent from the CPU to other devices, or other devices may send their status to the CPU. So the control bus is unidirectional, but its direction can be either from the CPU or back to the CPU. The data bus is bidirectional, because data can be transmitted from the CPU to other devices, or from other devices to the CPU. Since the data bus always has a bidirectional direction. The above is an overview of the microcomputer system. In the next section, we will learn about the CPU. See you in the next class.